6.6 RSG. We're only going to do the ready and the go here. We're going to skip the set. It's a neat little activity that you guys are welcome to do, but I'm not going to take the time to discuss how to do it. My hope is just from this that you guys will be able to find arc length and be able to convert back and forth from degrees and radians. So we're going to start with arc length, and that's the ready. Arc length is the radian measure of a circle. It's the piece of a circumference. So when we were building our unit circle and we were learning that, we found all the different radian measures throughout the circle. And it was the distance from the initial side. And it grew as we went around the circle, and it ended with 2 pi. That was our final arc length. And the more you travel around a circle, the arc length increases. What we're going to do now is be given an angle measure, and we want to find the arc length. If I were following a path on that actual outside of the circle, how far are you actually walking? So we have a formula here. This formula is all fine and dandy if you're given the diameter. One of the things as you progress through upper level math classes, we kind of start to move away from degrees and we move into radians. In math analysis, it's radians. In calculus, it's radians. So I want to discuss this as if you were given theta in radians. Now on your unit circle, let me get rid of this over here. On your unit circle, your radius is 1. So when we are dealing with here's pi over 6, here's pi over 4, here's pi over 3, here's pi over 2, and so on and so forth, that is the radian measure from 0 to 30 degrees. It is pi over 6. That's the actual length on the circle. So it changes as your radius changes. So we actually use the radian measure of the unit circle and we multiply it by the radius. So in math analysis, the formula for the arc length, and S is our symbol for arc length, is your radius times theta, whatever theta is. So if your radius is 1, then you actually do get to use the unit circle. When your radius is not 1, you use your unit circle to find the radian measure, and then you multiply it by the radius. Now sometimes those radian measures are not on your unit circle, and if you're given it to you in degrees, you are going to have to convert. So there's also a formula that has the conversion built in. So this formula is when theta is in radians. And then the R stands for radius. So those are the two things that you need to know. Now let's say your theta is given to you in degrees like it is in the homework. In Math 2, you guys go over how to convert from degrees to radians. It's rather quick, but you do go over it. And if you have theta in degrees, you actually need this to be converted to radians. So we multiply by pi over 180. And I'm able to do that because my radius is the radius. The formula that they give you guys in the homework is theta over 360 times diameter times pi, because they are using diameter instead of radius. But if I convert diameter to radius, diameter is 2 times r. So this is theta over 360 times 2r times pi. Well, 2 goes into 360 180 times. And look at that. We end with r, theta, and pi over 180. So same thing, you guys, they just have a different conversion built in. I don't care which one you use. If you are given theta in radians, then you need to use this one, but these two, I really don't care, whichever one you want to use. Now what's nice with the problems in your homework, 120 degrees, well guess what? That's on your unit circle. So if I go to 120 degrees on my unit circle, I see that the radian measure is 2 pi over 3. So if I use r times theta, theta's in radians, this is the same as 2 pi over 3. That's my other theta. My radius is 10. This is 10 times 2 pi over 3, which is 20 pi over 3. And I want you to leave your answer in pi. I also want you to simplify your fractions. You really need to completely simplify. If this was 20 over 6, hypothetical, that was 20 over 6, you would not be done yet. You need to simplify completely. So that was nice because it was on your unit circle. Now let's pretend that you don't recognize that 120 is on your unit circle. I don't want to use this formula. There's just too much going on there. And I know the radius. So I'm going to use S equals R times theta times pi over 180. So here's my theta, here's my radius. 10 times 120 times pi all over 180. So I'm going to do some multiplication. 10 times 120 is 1200 pi over 180. Now I can cancel a set of zeros. Now 120 and 18. I'm going to start by checking with my calculator if 120 divides by 18, and it does not. I know that I can, sorry about that guys, I know that I can divide by 2, but I want to see if I can divide by anything bigger. 18 is divisible by 6. Ooh, 120 is divisible by 6. When I divide 120 by 6, I get 20. When I divide 18 by 6, I get 3. Oh, that's the exact same answer that I ended with the first time. So you guys can decide how you want to go about this. You do have the freedom here to choose because you're very lucky and all these values are on your unit circle. And since we've already gone over the unit circle, that's kind of a nice little cheating tool for you. But you may also want to practice using this formula because the value won't always be on your unit circle. So maybe try both. Practice both. See that you get the same value. You're probably like, ugh, that's too much work. Well, do you want to get it or not get it? That's completely up to you. You guys can decide. And then number 6, the circumference of a circle is 400 meters. The circumference of another circle is 800 meters. What is the relationship between the radius of the circles? So you need to find the radius. So just remember, circumference is 2 pi times diameter, or 2 pi times diameter. Sorry, I don't know what I was thinking there. I don't think I was. All right, let's move on. And the set we're going to skip. You're welcome to try it. Read the directions carefully. Don't pick a word that's very big. The bigger the word, the more complicated everything is going to be. All right. Not worried about that. I mean, it's good that you guys can answer these questions if you guys do this, but I'm not too worried about it right now. I know that sounds really bad, but it is what it is. All right, the go. The go is centered on focusing between conversions of radians and degrees. So they have a lot of words here. Recall that 360 degrees is a full circle and 2 pi is also a full circle. Therefore, 360 equals 2 pi. So if we simplify this, I'm going to simplify. So if I take 360 over 2 pi, so I write a ratio, 360 degrees divided by 2 pi. If I divide both of them by 2, I get 180 over pi. I can't simplify that any further because 1 pi is 1. That's the smallest that it's going to get, and I don't want to deal with other fractions. So 180 over pi. This ratio will help us convert from radians to degrees and degrees to radians and vice versa. I will be using both of these. So if I want to go from radians to degrees, I will multiply my radian by 180 over pi. If I want to go from degrees to radians, I will multiply my degrees by pi over 180. So I'm going to keep using that ratio. The ratio works because they are equivalent and they give me 1. When I multiply these two together, I get 1, which is what it's talking about back here. So here, in this example, they want to convert 72 degrees. So you have to take 72 and multiply it by pi over 180. So let's work out their example so maybe it's a little bit easier to understand. So 72 degrees times pi over 180. I want radians, so pi needs to be in my numerator. So this becomes 72 pi over 180. And now it's a matter of simplifying. So 72, I think I can divide. Let's see first. Always check first to see if you can divide the big number by, so 180 by 72. 180 divided by 72 is 2.5. So it doesn't quite divide nicely. So I'm going to take 72 and I'm going to divide it by, let's see, 36. 72 divides by 36. 180 also divides by 36. So if I divide both of these by 36, and you want to divide by the largest number, you're welcome to divide by 2 and 3 and 9 and 6. You're welcome to divide by those, but you're going to have more division that you will need to do. So 36 goes into 72 twice, and 36 goes into 180 5 times. So this is 5 pi over 2 radians. And then what's their other example? Let's see. And by the way, it looks like their example is completely wrong. That they have pi over 5. And if you're looking at that, you might be like, what the heck? It's 72 does not go into 185 times. That just mathematically makes no sense at all. It actually goes in 2.5 times. So ignore the work that they have there in the book. Let's do a radians to degrees. So let's do an example off to the side. Let's say that we have 3 pi over 7. And I want to convert this to degrees. So I'm going to multiply by 180 over pi because I need my pi to cancel. So now they do. My pi's will cancel. And this is going to become 3 times 180 all divided by 7. So I'm going to multiply 3. Well, and nothing is going to simplify. I would want to try right now to see if I can simplify before I multiply. 7 does not go into 3, and 7 does not go into 180. So I'm going to do 3 times 180, and I get 540 over 7. And I'm going to divide, which gives me 77.14 degrees. I actually want to get a degree that I know where that is going to end up being. The radians, I want to leave it in terms of pi because that's how I have radians on my unit circle, and I can figure out where 2 pi over 5 is, roughly. And now I can figure out where 77.14 degrees is also. So that's it on conversions, and you have some, like 6 of each that you guys can practice. Notice how some of them are on your unit circle. I would like you to practice using the conversions first, but then use your unit circle to verify that, yep, that's correct. I found that fine and I did good. So that's it for 6.6. Please be ready with questions for our homework day, and I will see you tomorrow.